So, can we go back and proceed? Let's proceed, okay?
Okay.
I was still explaining something on how to present answers, how you should present our work, okay? Are we there?
Yes, sir.
Yes. So we are saying the key words. What I'm interested here is the key words. You may not write exactly the way I've written mine, okay? You don't need to cram the way I've written mine. Right together. This is how I can present mine. But for you, what I need from you is to take the key word. So in this, when you look at my answers in this question, what will be our key word? The keyword will be what? Momentum, right?
Momentum.
And then what? And then what? And then collusion.
Collusion.
Then resulting into impulsive force. I think that. So when presenting answers along this, the keyword I want to see is momentum. Is momentum on collusion. Now, when you come to momentum, you have to be specific because we have low momentum and high momentum. Right together. Because a body can have low momentum or high momentum.
Yeah.
So low momentum is because of low velocity, right? It's brought due to low velocity. This one means low velocity. So this one is brought because of high velocity. Right together. So since now the person is riding a motorcycle at high speed, which means the cyclist will produce high momentum. That's why you are seeing that I put high momentum. Right together.
Yes.
Yes, that's why I put the high momentum. Then after that, then on collision or on colliding with the raindrops. Now that one, now you bring the rate of change of momentum is high. And remember we said that the rate of change momentum is the same as the impulse. So which means the higher the rate of change momentum, the higher the impulsive force exerted on the person, or the higher force of impact on the body. So that's what we are saying now. Hence resulting into a high impulsive force on the person. That's why the person feels as if the rain is heavy. Right together?
Yes, sir.
Yes, that's how you should present your answers. So the same concept is applied in question 2. The same concept is applied in question 2 and question 1. So what I'm interested most when you're presenting, you don't need to cram what is in the textbook. Just look for the key words and try to frame yours. Are you together?
Yes.
Yes. Now I think we are good to go. We are good to go to the next concept. Now let's move to Newton's third law of motion. Stop heading. Newton's third law of motion. Newton's third law of motion. And this is a very interesting thing now. This is the most important, interesting thing in physics, and we have all experienced this. Now, let's take example. We have all witnessed this. If you are jumping, there's that reaction you get. So Newton was that reaction can be in terms of pains, or can be in terms of how you feel. You get it? I get me. Can be in
Yes.
Yes, sir.
Yes. Like you can imagine when you punch the wall, when you're punching maybe a punching bag or the hard wall. Say for example, if you are punching a wall, assuming you are using the same force, using the same what? Using the same force. You are punching a wall, and maybe as, say for example, a hard wall, let's say hard wall, and maybe mattress. You are punching a mattress or a punching bag. Which one do you feel much pain and why? Yes? Which one do you feel much pain? Between the walls and the mattress when you're punching. Which one do you feel much pain?
The wall.
The wall.
Why? Why?
Hard.
Was. Teacher, because it's hard.
It's a hard surface. So which means,
Sorry,
and the force of the reaction you get, okay? The force you are applying, that is the action. Right together. The force you apply, that is the what? The action.
Action.
Then the reaction is the pain you feel now. That's what you see in most sports. In most sports, like in the athletes, in athletics, sorry, you find that they jump on smooth surface or on soft surfaces. Why? Because they want to minimize that reaction. Because the other the surface, the what? The more pain you feel. Right together. So you find that for mattress is smooth. So which means the force, the action may be big, but the reaction is very small. Is minimum. Sometimes even can be neglected. Sometimes can be neglected. So here in Newton's third law of motion, we talk of action and what? And reaction.
Action.
And Newton was very conscious, and he said now we are stating. Can you write it down? Newton's third law of motion states that. Newton's third law of motion states that. Newton's third law of motion states that. To every action, to every action, comma, to every action, there is equal and opposite, there is equal and opposite reaction on a body. To every action, there is equal and opposite reaction on a what? On a body. Right together?
Yes.
Yes. Are we together?
Yes, teacher.
Yes. So in Newton's law of motion, we are looking at basically actions and reactions. The action is the force you apply. The reaction is how you feel after applying the force. Okay? We can look at that because we can see right now you are seated, right? I know you are seated unless if someone is standing again there from there. I know we are all seated. When you are sitting on that floor, or on, either on the floor or on the desk or on a chair, there's a reaction. There's a force you are applying on it. And that force is your weight. That force is your what? Your weight. And what is making you to be stable, seated comfortably there, is because of the reaction from the chair. Are you getting me, members?
Yes, teacher.
If this, take for example, if this is now what we have, this is the table, and there's this block there. This is the block, okay? This block has the weight. So it's going to exert the weight down. So this is the weight, mg, okay? That's the weight. But on this surface, between the block and the table, there's a reaction. There's a what? A reaction. And that reaction, remember we said they act in opposite? They act in opposite direction. So which means if the weight is acting downwards, which means the reaction, what we call the normal reaction, it will be upward. So this is what we call normal. Normal what? Why do we call it normal? Because it's perpendicular. Because it is perpendicular to the surface. Because it's perpendicular to the surface. Right together. So, that is one example we can give. A block resting on a table is exerting a force on the table, and there's equal force but opposite reaction on the table. And that reaction we call it a normal reaction. Another example we can also give. We are able to walk. Is because of Newton's third law of motion. We are able to walk is because of Newton's third law of what? We are able to walk is because of Newton's third law of motion. If this is the person, you are there, this is how you are walking. The person, you are there, this is how you are walking. I think that. Right? I think that. You find that when you move forward, that's That's why you see that when you are walking, one you move forward, and then one leg is backward. So this one is the action. This one is the action. This is the reaction. On the ground. Okay. This is forward. This is forward. Then this is what? Backward. So this is the reaction. Backward. This is the reaction. And that is it. This is the reaction. Are you getting that? Are you together, members? Are we together?
Yes.
Yes, teacher.
Okay. You can see what's on the one on the screen. That's what I was trying to explain there. That's what I was trying to explain there. So we can see, we say, for example, a glass block resting on a table, a glass block resting on a table, exert a force equals to its weight onto the table. So this force is called action. But at the same time, the table exerts an equal force on the glass block, but in the opposite direction. And this force is acting in the opposite direction is called reaction. Are you together? So in this case now we can say, so that's why now you can see that the block is very stable on the table. It is because action is equals to what? Reaction. So if action is equals to reaction, that now explain what we call the Newton's third law of motion. Are we together?
Yes.
Yes.
So the action and reaction, note, action and reaction act on different bodies, in different directions, and they act in different directions. So the net resultant force on the body, is zero. So the net resultant force on the body is zero. So let me explain that one. So if this is the surface, we have a surface there, then we have a block there of mass. So it's exerting weight, force, which is mg, and there's a reaction there, R, okay? And this is the surface. So we are saying that since from Newton's third law of motion, for this block to remain stable, or to remain at rest, or to continue lying there like that, these two forces must be equal, but they must act in opposite direction. Right, together. So what we talk of the resultant force, remember we said F is equals to ma, right? Where F is a resultant force. And since this is a horizontal motion, is a vertical motion, which means the acceleration will be equals to v. That's why you see that we have the mg. Right, together. So the resultant force, when I get the resultant force of this, so our resultant force, since they're acting in opposite direction, if forces are acting in opposite direction, what do we do? Do we add or subtract?
Subtract.
So we subtract. Which means we can say R minus mg. In this case, minus mg. So in this case, since they are equal in magnitude, R and G, they are equal in magnitude. So which means R minus mg will be equal to 0. So the resultant force will be 0. So R will be equal to m what? R will be equal to. Are you together?
Yes, teacher. Yes.
In this case, the normal reaction will be equal to the weight. Yes. So we can give example on that. Can you write this? Can you write this one down? Write this one down. Newton's third law of motion. Newton's third law of motion is not on the screen, please. Newton's third law of motion helps us to explain the following phenomenon. Newton's third law of motion helps us to explain the following phenomenon. Phenomenon is this. Newton's third law of motion helps us to explain the following phenomena. Number one, it helps us to explain, number one, if you push a wheelbarrow, if you push a wheelbarrow on a slippery, ground, comma, you may fall. You may what? You may fall. Is it true? Is that one true? If you push a wheelbarrow on a slippery ground, you may what? You may fall. Is it true? Is it true? Yes. Yes. That's the first one. Then number two, if you eat a wall, with a greater force, comma, you add yourself. Yourself. Okay? Number three, a swimmer in water pushes his hand backward. Have you ever asked yourself why is that when you are swimming you have to push your hands backward? That one is also being explained by Newton's third law of motion, where for every action there must be equal but opposite. When you push your hands backward, the reaction will be what you push to move forward. That's why you're able to swim comfortably. Then number four, another block used by athletes. A sprinter uses starting blocks to give him or her sufficient force while starting. I believe I've seen when you see like in Olympics and every sport arena, those one who go for 100 meters, those are the sprinters. When you see them going for 100 meters, you see where they're starting from. The starting block. Have you seen that starting block? That starting block is to help them give a sufficient force, which is the action, so that they can start easily without any difficulty. Okay? So that's also, that idea also came from Newton's third law of motion. Then lastly, when two cars collide, when two cars collide, or two bodies collide, they both get damaged. They both get damaged. They both get damaged because each car exerts an equal but opposite force. Are you together?
Yes.
Yes. So those are the 5 phenomena which we can use to explain Newton's third law of motion. Which we can use it to explain Newton's third law of motion. So write down this sample question. Write down this sample question. There's one that I've not given among these, but I want to put it in terms of questions, okay? The question is, explain why. Sorry, explain what happened. Explain what happened. Explain what happened. Explain what happened to a balloon. Filled with air, and released in space, with its neck open, with its neck open. I'm giving answer to that. Okay? But whatever question you see along this, among the 5 or the 6 phenomena that we have given, it will just rotate along Newton's third law of motion, action and reaction. Right, together. Members, are we together?
Yes, teacher.
Yes. So the answer we will give to that, the balloon, I'm giving the answer to that. The balloon moves in opposite direction. The balloon moves in opposite what? The balloon moves in opposite direction to that of the escaping air. Okay? This is because as the air escapes from the balloon, members, are you following me?
Yes, teacher.
Yes. I'm just giving it because I want you to put. That's why I'm able to write. The balloon moves in opposite direction to that of the escaping air. That's the first one. We have all seen that. This is because as the air escapes from the balloon, it produces momentum. It produces what? Momentum, which is action. This momentum, I'm giving a solid answer to that. This momentum or action due to escaping air, sets up equal, should be equal, but opposite opposite, forward momentum, forward momentum, opposite, forward momentum, which is now, this one is our reaction. Now this is the reaction now we are talking about on the balloon, on the balloon, and causing it to move forward, and causing it to move forward. Are we together? Numbers, are we together?
Yes, teacher.
Yes. So that's the solid answer like I've explained. So when you are giving, you look for the keywords. You look for the key words in a given explanation. So the key words there, I want action and reaction. Action and reaction, which must be, and then another term we have introduced there is momentum. So momentum, opposite direction. Those are the keywords I want to see. The reaction, making it to move forward. I think those one are highlighted. You have seen that, right? Members, are we together?
Yeah. Yes, we are together.
Okay. So the question can be set among the 5 phenomena we have given them. We have given down there. Could be in terms of cars, can be in terms of the balloons, can be in terms of the athletes, why the sprinters use as a starting block, can be the table, okay? Can be, now you can you see what is in the note? Another example can be, why is that when you're jumping from a boat, you find that you move forward, but the boat move backward. I think that. We have all experienced that, right? Then another example we can also have a gun and a bullet. The propulsion of a bullet from a gun. The bullet will move forward, but the gun will move backward. The bullet will move forward, but the gun will move backward. So that one also explains Newton's third law of motion. That one also explains Newton's third law of motion. Are we together? Are we together, members?
No.
Are we together?
Yes. Yes, teacher.
Okay. Now, let's move to another concept. That is it. What we have written, that is horizontal motion. Now, let's look at application of Newton's third law of motion. Application of Newton's third law of motion. Application of Newton. Application of Newton third law of motion. Okay. Number one, a book, the first application, a book resting on the desk or a table. This one I'm just going to make recaps of what you have already looked at, okay? A book resting on the desk or on the table. Can you draw this? Draw for me this. I'm just going to make recaps of what we have already given. This is the block. This is the block. So there will be weight. So this is it. Weight. G. We know that there will be the reaction, right? So that's the reaction. So this is the block, or can be the book. Okay. Then this is the table. This is the table. Draw for me that, please. Draw for me that. Explanation. I'm giving explanation for that. Explanation. Explanation. Can you write this? When a block or a book, when a block or a book rests on a table, comma, it exerts an action, on the table due to its weight. Also, the action takes place vertically downwards. And as a result, the table reacts vertically. Now this time the table will react vertically upwards. Okay? Due to Newton's third law of motion. Are you together, members? Are you together?
Yes, teacher.
Yes. So the block will exert a force on the table due to its weight. Then the table will react vertically upwards, and that force is what we call the reaction. Remember, from Newton's third law of motion, both action and reactions are equal, but only they're acting in opposite direction. Are you together? Yes. That is the first application of Newton's third law of motion. Then number two, motion of a lift or of elevator. Motion of a lift or of elevator. So that one we shall look at it when we come back again. Our time is running out, so that's why we shall continue from there. We shall continue from there next time. Okay? Are you together, members?
Yes.
Yes. So you can see from the notes, motion of a lift or of an elevator. I will explain what you are seeing in the notes there. What am I liking? I will explain all that. But that's what we can do for now. Is there any question? Yes, Beatrice?
Yes, teacher.
You came late. Why?
Yes, teacher.
You came late. What happened?
Yes, teacher.
You came late.
I woke up late.
You woke up late.
I woke up late.
But you have understood, right? Beatrice? Frida? Manya, you also came late. Frida, you also came late. Even Bazara came late. Now, members, I remember the other time giving this assignment, but few people have responded. I think this assignment here. We have finished section B. I mean, we have finished section A. Section A, we have already answered. Section A, we have already answered this. Nalo Kenge.
Yes. Yes.
It's only Nalo Kenge who have submitted our work for section A. The rest, I don't know what happened.
Yes.
The assignment I'm giving now, I think section B. Yes, work out to the section B now, all of it. Section B, all of it. Okay?
Okay.
Yes, there are
Okay.
8 questions.
Okay.
When we meet on Friday, is it Friday or when are we meeting again for physics?
Friday.
Yes. We shall finish, when we meet on Friday, we shall finish the remaining part of Newton's third law of motion. After that, then we revise this part. Okay?
So section B is like singer.
Are we together?
And you're like, what?
Yes, teacher.
Everything goes up.
Yes, teacher.
Yes, Emmanuel? Emmanuel, I'm seeing your hands up.
Teacher.
Yes?
Teacher. Your WhatsApp number. Your WhatsApp number. Teacher.
Yes?
Teacher.
Okay, my WhatsApp number. My WhatsApp number, please. Can you write it down?
I can submit the work.
I'm writing the number on the screen there. 077 67 89909. That's submit the work on that number, okay? Okay? Members, have you seen it?
Yes.
Yes. Those who don't have my number, that's the number. Use it to send the work. So, Beatrice.
Yes, teacher.
Since you came late, you're going to give us a closing prayer. So give us a closing prayer, please.
In the name of the Father, in the name of the Father, and of the Son, and of the Holy Spirit.
Amen.
Father, we thank you for this lesson. We thank you for the gift of life you have provided for us. We thank you for our teachers. We thank you for everything you have done for us. Father, I thank you for the lesson we have learned today. Father, may we understand. Father, I pray for the Holy Spirit to touch us so that we may understand everything and cooperate with our teachers. In Jesus' name I pray.
Amen. Thank you. Beatrice has prayed for cooperation. So let's cooperate. Okay?
Yes, yeah.
Yes.
Yes.
Before Friday, I want to see all the work.
Okay.
Okay?
Okay.
Okay, let me give you time to prepare for the next lesson. Have a nice day.
I
Thank you, teacher.
Love you.
Thank you, teacher.
Love you.
We love you too, teacher.
All right.
We love you too.
All right.